Okay. We started this topic last time, which is volume studies, and up till now we have just gone through the basic concepts. Okay. For example, that the things which you already know: volume, rate of flow, demand. Okay, the units and so on, and the variation in demand, and moving on to real-time management of traffic. Some examples which show the changes in demand. Then the last thing we were discussing was intersection volume counts. Okay, another name for it is turning movement counts. Okay, so we discussed.
What I have to do with check. I can't do
Don't do this.
Okay. It says I wouldn't.
No.
You call it?
No. If you were new to my class, that would be easier. No, I get angry. Okay. So returning movement counts. Then we discussed where should we place the observer, how should we use them, and so on. Okay. One thing which we discussed over here is that the observer should count the vehicles when they are leaving the intersection. Okay. When they are departing from the intersection, which means either they cross the stop line if they are going straight, or they reach the other side if they are turning. Okay. But the problem comes when we have a very long queue at the intersection. Okay. Because at that time your volume does not show the demand of the intersection. Your volume is only showing the capacity of the intersection. The maximum number of vehicles that are passing through the intersection, this is what you are observing. Okay. But the actual demand is in the queue. The people who are waiting in the queue. Okay. So you don't want the people who are leaving, you want the people who are coming. Okay. But we mentioned earlier that the queue itself is not static. Okay. Queue is not fixed at one place. Queue goes forward and backward. Okay. So now the problem is how to get the demand with this movement of the queue. Okay. So for that we have this equation. Okay. But we need to decide when we will shift from the departure to arrival. Okay. So I am doing survey for, let's say, 3 hours, 4 hours. Okay. Maybe out of these 3-4 hours, there is only 1 hour when the queue is very long. Okay. For the remaining hours, the queue is normal. The operation is normal. Okay. So I need to decide when should I shift from the arrival to departure. Okay. So they have given us a couple of indications. They call it the queue build-up case. Okay. They call it the queue build-up case, meaning the queue is increasing. Simple. Queue build-up meaning the queue is increasing. Okay. So what are the indications of queue build-up? If you have a signal, okay, and vehicles do not find the chance to clear the intersection in one green. Okay, vehicles which are in the queue, they do not find the chance to clear the intersection in one green. The queue is 20 vehicles, the green happens, all 20 vehicles go. This is not queue build-up. But out of 20, only 10 are able to go, and the remaining 10 are still in the queue. This is queue build-up. Okay, earlier we called it overflow. Okay, in the delay studies we called it overflow. Okay, so overflow and queue build-up means the same thing. Okay, for signals. If the intersection doesn't have a signal, then you just look at the length of the queue. That's it, simple. Okay, because on a signal, the queue, when the signal is red, the queue will increase, right? In any case, the queue will increase. Okay, so you can only say if it's queue built up when it happens during green. So that's why we have this, that all the vehicles do not leave from the intersection. Then queue built up. Okay, for signals. But for normal intersections, roundabout, stop signs, if the queue is increasing anytime, this is queue build-up. Alright. Okay, so you like look at the road for couple of minutes and you see the queue was here, now it's here, now it's here. So every time it's increasing. This is queue build-up. Clear? Okay. So whenever we have queue build-up, we will go from departure to arrival volume. Okay. We will not, or we don't want the vehicles which are leaving the intersection. We want the vehicles which are coming to the intersection. And what are the indications? Queue build-up. Okay. For signal, when the vehicles do not move or do not clear during the queue build-up. For other intersections, when the vehicles in the queue are increasing. Okay. Now we said the queue is moving, right? It's moving forward and backward. Now where are the vehicles coming? The start of the queue or the end of the queue? Huh? By start you mean what? The back side, right? Okay. The vehicles which come, they are coming where? At the start of the queue, right? From where the queue has started. So every time a vehicle comes, the start of the queue is moving back, right? Now there were 10 vehicles, a new one comes, now it's 11 vehicles, right? A new one comes, now it's 12 vehicles, and so on. So the point where you want the reading, where you want the observation is moving, right? Okay? So we cannot directly take the number from this point because this is not a static point. Okay? It's not a single point that I will observe the vehicle now, here. This is the start of the queue down. But maybe after 10 seconds it will be there. Okay? So we want the vehicles which are coming at the start of the queue. But I cannot see them directly. Because they are not coming at the same point. Understood? Huh? You got the issue? What is the issue? Okay? The point which we are looking at the point where I need the observation, that point is moving. Clear? Okay? And at some point the queue will move forward as well, right? It's not only moving back and back. Sometimes it will move forward as well. Okay? So my observation point is moving. Okay? So I want the observation at the start of the queue. But the start of the queue is not a fixed point. Okay? So what we will do, we will calculate the number of vehicles arriving through calculations. Okay? Through an equation. And this is the equation over here. Okay? VAI means vehicles arrived during time interval I. Okay? Vehicles which have come to the intersection during time interval I. Okay? VDI, vehicles departed, vehicles which have left the intersection in the same time interval. Okay? So I am trying to calculate VAI, but I am using VDI. I am trying to calculate number of vehicles which came, but I am using number of vehicles which are leaving, because the number of vehicles which came, I cannot directly see them. Okay? Clear, everybody? Okay. Then what is NQ? NQ is number of vehicles in the queue at the end of time interval. Number of vehicles which are in the queue at the end of time interval. Okay. So NQI means end of time interval I. NQI minus 1 means at the end of previous time interval. The one before I. Okay. Let us see how it is applied with this example. Okay, first of all, look at the first column. What is my time interval? How many minutes? 15 minutes. Okay, so I want how many vehicles arrive for 15 minutes. Okay, now second column, how many vehicles are departing? Okay, so leaving. So I am still counting at the stop line. I am not counting the start of the queue because I cannot do it. Okay, it's not a fixed point, I cannot do it. So I am still counting the easy one. The ones which are leaving. Clear? Okay. So then you see the third column is Q, right? Okay. And Q, number of vehicles in the queue. Okay. Now when I say, for example, if you look at the second column, 50, right? It says 50. 50 vehicles departed. 50 vehicles departed from 4 to 4:50. Okay. Clear? But when I say Q length is 0, it means Q is 0 at 4:15. Okay? Maybe at 4 there was a Q. Maybe at 4 or 5 there was a Q. I'm not interested in all these values. This is the last value. So 0 is the last value. Clear? Okay. Now, if I want the number of vehicles arrived, for the first time interval, okay, there are 50 vehicles which have left. Do I have any queue now? No. Do I have any queue from the previous time interval? No. Okay, so it will be 50 plus 0 minus 0. Okay. If there were more vehicles which arrived, they will be in the queue, right? If their number of vehicles which arrived were more than 50, they will be in the queue. Is anybody in the queue? No. Okay, so there's the arrival is departure, same. Clear? Okay, next one. Same thing, right? 55, no queue now, no queue before. So 55 is my arrival as well. Okay, now next one. 62 departed. Okay. But are these 62 the only ones which came to the intersection? No. Because I have now 5 left in the queue as well. Okay, so total which arrived is 62 plus 5. I'll do minus 0 for the equation as well. The equation says subtract the previous queue. Okay, so plus 5 is the present queue, minus 0 is the previous queue. Okay, so now I have 67. Clear? Okay. Then the next one is 65. Okay, I will add the queue now 10 minus 5. Because out of these 10, 5 are already in the queue, right? I don't need to add them again. So minus 5 and we're 70. Got it? Clear? Okay. What I am doing here is this equation. VDI is the number of vehicles departed, and QI, Q now, and QI minus 1, Q before. Okay, clear? So, in the same way you can calculate the rest of the values. Okay, clear? Any questions? Now, if I reach the end, the last value, can somebody tell me the last value? What will be the last value in this column? 55. Why 55? Yeah. Like we did not have, like these values were same at the start. Why they were same? Because no Q now, no Q before. Same thing happens here. So last value should be 55. Okay? And the total here is 469. Okay? If I do the total of this column, it should also be same rule. If there is no Q, that means arrival and departure are same. Clear? Okay. Okay. Some more points which you need to keep in mind if you are doing the counting at signals. Okay. The first thing is, at signals the movements do not happen at the same time. All movements do not happen at the same time. Okay. At signals you have more margin to assign more observations to one observer. Okay. So I know left turning and straight, they are happening in different signals. Okay. Different times. So maybe both of them have heavy movement, but still one person can do it because they are happening alternately. Okay. Second thing is how much time you will give the observer for counting and how much time you will give him for break. Okay. Now I mentioned cycle last time. What do you mean by a cycle? What is the cycle of a signal? From red to red. Okay. And there is a time which the signal takes from one red to the next red, right? Okay. Now your observation time and your break time should be a multiple of cycle length. Okay. So for example, your cycle length is 60 seconds. your observation time should be a multiple of 60 seconds, and your break time should also be multiple of 60. Okay, that means total will also be multiple, right? Observation plus break will also be multiple. Okay, so whatever timing you are setting for the observer, whether for counting or for break, all of it should be a multiple of the cycle length. Clear? Okay. Now this can happen very easily if the cycle length is fixed. Okay, the signal takes the same time to go from red to red throughout the hour, no problem. Okay, but there are some signals which have sensors attached to them. Okay, even in Bahrain we have these signals which have sensors attached to them, and these sensors provide traffic data to the signal, and then we program the signal to change timing according to traffic data. Okay, they are called as actuated signals. Just mentioned this. Okay, these signals which are attached with the sensor, they are called as actuated signals. Okay, now if the cycle length is not fixed, how can I take a multiple? It's 60 seconds now, but next 5 minutes it will be 70 seconds. Okay, so I take a multiple of 60, next 5 minutes will not be valid. It will be wrong, right? Okay, so what do we do in that case? We take multiple of maximum cycle length. Whenever we have an actuated signal, we set limits for the signal. It will change timing in these limits. It will never cross the limits. Something we should all do, right? Right? So the signal will not cross the limits. Okay, it will not go above maximum. It will not go below minimum in any case. Okay, so that value is fixed. I need a fixed value, right, for the multiple to take the timing. I need a fixed value. So in the first case, without actuation, my fixed value was the actual timing of the signal. In the second case, my fixed value is the maximum cycle. Okay? Clear? Okay. Now what is the reason behind it? Why we are taking multiple, and then why we take multiple for the maximum. Now imagine the signal is 60 seconds, right? The signal is 60 seconds. You tell the observer, you count for 5 minutes and then take a 30 seconds break. Now 5 minutes is a multiple of 60, right? 60 seconds means how many minutes? 1 minute, right? Okay. So 5 minutes is a multiple of 1 minute, no problem. But your break time is not multiple, right? You give him a breakdown of 30 seconds. This is not multiple of 1 minute, right? Okay. So what will happen now? He will finish one. Okay. One interval, 5 minutes, right? In 5 minutes, one cycle is 1 minute. So how many cycles? 5 cycles. Okay. Then he will take a break of 30 seconds, right? Now he missed how many cycles? 30 seconds. If one cycle is 1 minute, then 30 seconds means he missed how many cycles? Half cycle. So he will start now in the middle of the cycle. Middle of the cycle means what? Maybe the half green already passed. Half of the green has already passed. So what we will count now? Only half of the green, right? Can you trust this observation? You cannot, because the time when he was supposed to count, he was taking the break. Okay, so if you are taking the count for half of the green, obviously you will get less number, right? Right or wrong? Sleepy? Yes. Stand up. Stand up, stand up. Yes. Sit down. Okay. So, if you do not make it multiple, then he will miss some of the green time. And the green time he misses, its value will be less. Not because of traffic, because of its break. Got my point? Okay, so that's how you want it to be multiple. Okay, there. Now what will happen when you have actuated signal? We said, okay, take the maximum of, take the multiple of maximum cycle length. But maximum is just one number, right? The signal could be operating at less than maximum. Maybe this traffic is less, so it's not having maximum. So you will miss some green times, right? You will miss some green times, okay? But for actuated signal, it's not a problem. Why? What is the purpose of putting the sensor? Why should you put a sensor to the signal? Huh? What about traffic flow? Huh? And this is not multiple choice question, okay? You have to like say a whole sentence. Traffic, what flow, what is this? To calculate the volume, okay, and then what the signal will do with the volume? What should happen with the signal time according to the volume?
Time of the signal. To change the time of the signal.
Okay, so more volume means more
More time.
more time, right? Okay. So this mechanism will take care of whatever error you are making by taking the maximum cycle length. Okay. So for example, I take 5 minutes. Okay, and in 5 minutes there were only 4 cycles, let's say, and there was one half cycle, let's say. In 5 minutes there was a half cycle. Okay. But if the volume in one direction was high, then because of the sensor, even in this 4.5 cycle, this side will have more time. Okay. Get my point? We were worried that I will miss some of the green time in which the flow is happening, right? Okay. Now the green time itself is changing because of the volume. Okay. So whenever I observe the signal, when I observe more time, it means automatically means more volume. Okay. Then even if I miss, okay, I will miss according to the same ratio. I will miss less of the green time for the side which has less volume. Got it? Okay. So that's why in actuated signal we don't need to worry about the actual cycle length. We take the maximum because we need a number and we go ahead. Okay, clear? Stand up. Are you aware? Down. Okay. This is how we represent the intersection turning counts. Okay. So the boxes show numbers, and each box is showing a different direction. Okay. So you can see how much volume is going from which side and where. Okay. So this 30 is taking right turn, right? Okay. And how much do I have total on this side? 750. This is from all the sides. Okay. This is one way of showing it, which is very easy. This is another way. Okay. So now you see arrowheads and tails, right? Okay. Tail means the volume is going. Head means the volume is coming. How much is coming from each side? The numbers are showing on the lines. Okay. The total is there in the arrowheads and tails, and the numbers are there on the lines. Clear? Okay. Another thing, for this diagram, we have the size according to the volume. Okay. So this one is supposed to be smaller than this one. The difference is very low, you cannot see it. Okay. But this one is supposed to, now you can see here and here. This is smaller and this one is bigger. Okay. Not because of the size of the street, it's because of the volume. Okay. And then we have this representation which is adopted in Bahrain, and normally when they show it like this, they can make a table as well. There is a table where they represent data for the whole day. Okay, but if they are only doing it for the peak hour, then this is how they do it. Okay. So the hours in which the study was done is mentioned, each with a different color, and then you see the same colors here as well. So you know this number is in which hour. Okay. The boxes are showing for each hour. Okay. And with each box you see the arrow to show the direction. Okay. The name of the roads are mentioned. Okay. And anything else which should be mentioned is also there. Okay, the date and time and everything. Okay. Up till now we have talked about locations, right? Single location, doing a study on a single location. Okay, but sometimes we need to do the study for the whole network of the roads. Okay, so we will discuss two cases in this category. Okay, one is limited network, the other one is statewide network. Okay, limited network means from the entire area you take a small part. Okay, why? Because we want to see the effect of a particular facility on that part of the road. So there is a facility, for example a school or an airport or a big shopping mall. Okay, something which they call as a traffic generator. Okay, a facility which generates a lot of traffic. Okay, like University of Bahrain. Okay, there. So we select a small part of the network which is around our facility, and we see the effect of that facility in terms of traffic. This is why we do limited network study. Clear? Okay. Now it is almost impossible to collect data on all roads and intersections of a network. It is almost impossible to collect data, full data for all roads and intersections of a network. Okay, because you need a lot of people, lot of money, lot of time, and lot of sensors and everything. Okay, so we don't do it. What we do is we take a sample. The same thing which we discussed for the speed and travel time, right? You cannot take the speed and travel time of all the vehicles. So we take a sample, right? Same thing is done for counting of a network as well. You have the whole network, I cannot cover it completely, so I will take a sample. Okay? Yeah, and then we try to find out the full count from the sample. In the end, I need the full count. Keep it in mind. Okay? In the end, we need the full count. Okay? But I cannot take it directly, so I will take a sample. From the sample, I will calculate the full count. Okay? Okay, how do we make samples? So, we select some of the locations, some, not all. Some locations to take full count. So, for example, full means the one which I need. Full means the one which I need. Okay, normally which is around 12 to 16 hours of the day, normally. Okay, so for example, the client tells you, I need 12 hours of data on this network. So my full value is 12 hours. Okay, but I cannot do it on all locations. So I will select very few locations for this full count. So on those few locations, I will take 12 hours. On others, I will not. I will take a sample of the 12 hours. Okay. The locations on which you take full count, those are called as control counts. Control is full. The other where you are taking sample is called coverage. Okay. So control is what? Full. And coverage is a sample. Okay. Other points which you need to keep in mind, all counts are taken on mid blocks. No count is taken on intersections. Okay. When you are doing a network study, we don't take counts on intersections. We take counts on mid blocks, meaning the segments, the roads. Okay. All segments must be covered, either with a full count or a sample. So if you have a segment on which you did not do control and you did not do coverage as well, then your study is not complete. Okay? At least one of them should be done. Clear? Okay. Now I told you control is full, right? And coverage is sample. So for example, if I have 50 locations in my network, which one of them should be more? Control or coverage? More locations should be control? which location should have full data, in terms of proportion. More locations should have full data, or more locations should have sample data. Which one is easier? Okay. Sample, right? Sample is easier. Okay. So we select more locations for coverage and less locations for control, because we are doing it to manage, right? This is from the point of view of management. Okay. So we do the easier one more and the difficult one less. Okay. So it's easier to manage. Okay. Clear? Okay. And what else? Yes. So we have a ratio here. We have a ratio. Okay. You can go from 1:10 to 1:20. For every one full count, you can have 10 to 20 samples. For every one full count in your network, you can go 10 to 20 samples. Clear? Okay. Now, can I take full and sample from any part of the road and any area? No. Okay. You have to identify in your network the type of road and type of area, and you cannot mix between them. Okay. For example, you can have in your network some roads which are arterials. Okay. And some others can be what? What are the other types of roads? Rural, urban, and what else? Collectors. Okay. So you need to identify which roads are rural arterials, which roads are urban arterials, which roads are urban collectors, which roads are rural collectors. Okay. And your full and your control and coverage count cannot be mixed between them. Okay. So if I am talking about an arterial, then I am only talking about arterial. My control is about arterial, my coverage is also about arterial. Okay. You have to take each type of road separately for control and coverage both. You cannot mix. Okay. And the same thing for the area as well. Type of area. Type of area means what type of activity is happening in that area. For example, we have education area, commercial area, residential area. Okay. So you cannot mix the counts of different areas together. Okay. You cannot mix the count of control and coverage of residential area with commercial area. Clear? Okay. So now you are selecting some locations for control and coverage, full and sample counts. When you are selecting, keep in mind, do the selection for every type of road separately and every type of area separately. Clear? Okay. So you will not have one set of points. You will have for every type of road a different set of points, and for every type of area a different set of points. Clear? They call it sub-network. Okay. They call it sub-network. Every part of the network, call it sub-network. Okay. So for example, this is our old campus in Easter Town. Okay. So here you have education area, right? And here you have residential area. Here you have commercial area. Okay. This is arterial. These are local streets. Okay. So you cannot say I will have control count here and coverage counts here, because they are different areas. Okay. And you cannot say I will have control here and coverage on these streets, because these are different types of highways. Okay. So you cannot mix the control and coverage of this type of highway with the local streets. Got it? Clear? Hala? Clear? Okay, let's start the example next time.